Hi everyone. Today we'll see few more problems on DC transients with the dependent sources. We have one current dependent voltage source. So problem statement, if you see, for the circuit shown in figure, find the current equation when the switch SC is changed from position 1 to position 2. Earlier the switch is in position 1. In position 1 the switch is for longer time, that is minus infinity to till 0 minus, because at t is equal to 0 only the switch is in position 1. At 0 it is reaching to the position 2. At 0 plus 2 infinity also it is at position 2 only. So that what it means. At t is equal to 0, when the switch is moving from position 1 to position 2, the circuit diagram will become, I'll redraw the circuit diagram here, 500 volts, 40 ohms. This side it is open because the switch is moved to position 2. Now the circuit will be closed in this way. The inductor current is I here. What is the first step? We have to apply the KVL. So apply KVL to this loop. If you apply KVL, 60 into I plus L into di by dt, 0.4 into di by dt plus, which is equal to, because this is plus minus, this is minus plus, is equal to 10 into I. So if you find out the solution further, 0.4 into di by dt, this 10 will go on the other side, 50 into I is equal to 0. By dividing on both sides with the 0.4, you will get di by dt plus 50 by 0.4 into I is equal to 0. You will get it as 125 into I is equal to 0. So di by dt plus 125 into I is equal to 0 is the first equation. By comparing this with the known differential equation, that is dx by dt plus px is equal to k, that is second equation, you will get x is equal to I, p is equal to 125, k is equal to 0. What is the known differential equation solution? X of t is equal to e power minus pt integral k into e power plus pt into dt plus c into e power minus pt. By substituting x, p and k values in the solution, I of t is equal to c, because this k term is 0 means the entire first term will become 0, only second term, that is c into e power minus p, p is equal to 125 into t, that is the third equation. So after getting this third equation, this is the complete solution, but you need to find out this arbitrary constant c. To find out this arbitrary constant c, use the initial conditions. What are the initial conditions? That we'll see. Initial conditions or transient conditions are t is equal to 0 minus, 0 and 0 plus. At t is equal to 0 minus, what is the switch position? At 1. Switch position is at 1. This is your switch position, right? Earlier. T is equal to 0 minus means here. Switch is at position 1. When switch is at position 1, this is a circuit diagram. 500 volt is connected through the 40 ohms and 60 ohms. But in steady state, earlier the inductor is there here. Inductor will get short circuit in steady state. Steady state means minus infinity to 0 minus. For longer time, it is in position 1. That's why inductor will get short circuit. When it is getting short circuit, the circuit diagram will be like this. So it is a current flowing through this short circuited inductor. I is equal to 500 by 40 plus 60. 500 by 40 plus 60, which is equal to 5 amperes. What is the inductor property? Inductor do not allow the sudden change in current. That's why even though it is moved to the position 2, like this, position 2, this is your position 2, the inductor will carry the same current, that is 5 amperes and 5 amperes. By using this, I'll use this initial condition t is equal to 0 plus, and I'll substitute in this third equation. I of 0 plus is equal to c into e power minus 125 into 0 plus. That is nothing but 0 only. E power 0, 1. You'll get the c as 5. So c is equal to 5. I'll substitute in the third equation to get the complete solution as I of t is equal to 5 into e power minus 125 into 2. So this is all about this problem. Thank you all.